Saxon Algebra 1, Lesson 20, geometry topic for today. Here's a quick review. When we measure perimeter, we are measuring one dimension, right? It's like a line. When we are measuring area, it's in two dimensions, and that's like a square. Piece of paper, maybe. When we measure volume, which is today's topic, we are measuring in three dimensions, and the best example of that is a cube, right? So our calculations have gradually progressed to be more complicated. There's a simple formula, though, for all the volumes that we're going to be calculating. They depend on an object being what we call a right solid, which means, and this is not a good example of it, a right solid means that everything is perfectly straight and perfectly square. There's no curvy edges. Everything is just super perfect, neat, and simple. And the way that we find the volume is that we find the area of the base of the object and we multiply it by the height. Write this down here in your notes. Then I will wait for a minute while you go and write this inside the cover of your, oh, mine's the plastic kind. I would have to write it on the back. I got one of these plastic types, but that's okay. Write it inside because you're going to want to remember that. It's super helpful, and volume problems become really great and straightforward when you can keep that in your brain. Okay, go write it. All right, let's start our volume problems with an old familiar friend. The base of a right prism is the isosceles triangle shown. Let me show you. This is the right prism. It's a triangle in 3 dimensions is basically what that means. And this is a picture that shows us just the base, okay? The height of the right prism is 6 centimeters. Find the volume of the right prism. Okay, so what I'm going to do is I'm going to copy this picture that shows us the base, because remember, volume equals area of the base times the height. That's my shorthand version of that formula we just discussed. This is the base, this triangle, right? So if I can remember that the area of a triangle equals base times height divided by 2, then I can find the area of this triangle. That will be the area of the base. Then I just multiply it by the height. What did I just say? Let's figure it out. The area of this triangle is base times height. The base is 4. The height is 8. And then we divide by 2 because that's just what you do. I'll cancel those, and I'll get that the area of the triangle equals 16 centimeters squared. We don't need to put a unit on it yet. This is important. Now I'm going to take this and import this into my big calculation. The volume is going to equal the area of the base, that's 16, times the height of, not the height of the triangle, but the height of the prism, right? 8 inches helped us figure out the area of the triangle, but now we want the height of the whole prism, and that is 6. So we take the area of the base, which we just figured out is 16, we multiply it by 6 for our height, and that equals 96 centimeters cubed. Our answers are always to the 3rd power because we're working in the 3rd dimension. Yay! Let's do another one. Some of these get a little nutty. The base of a right prism, 8 meters high, is shown. Okay, this is the three-dimensional thing, right? That looks complicated and hard, doesn't it? Find the volume of the right prism. Dimensions are in meters. All right, so again, what I'm gonna do, this time I'm gonna put the unit down. I didn't do that this time. I'll cheat and fill it in at the back. I'm not gonna try and draw that three-dimensional shape. It doesn't really help me that much because there's no numbers, but I am going to draw this. This is the area, the picture that shows me what the base looks like. And that's where my calculation starts, right? I always have to do that first. Once I get the area of the base, multiplying by the height is easy. That's not anything at all. 4, 6, and 10. I'm getting this all out of the book. I'm copying straight out of the book. Okay, now, in order to solve this, though, I need some information that's going to help me. I'm going to mentally do that. I'm going to call this the 1 and 2 just to help me. I'm calculating here the area of the base, right? That's what I did first up here. I'm going to do it here, but now it's going to have multiple steps. I'm going to have to do first this square. I'm going to do length times width, right? And let's see, it's going to be 4 times, not 10, 4 times 6, right? 4 times 6, that's 24. Now I need to do the triangle. That's base times height divided by 2. Notice the 1 and 2 match to these calculations. That's base times height divided by 2. The base is 10. No, it's not. That's not right at all. This much is 4, so this much must be 6. The height, look, is also 6. That's where my spider is sitting. Thank you, Charlotte. So this is the height, 6 times 6 divided by 2. With me so far? If your head's spinning a little, I know, it's crazy. This I'll cancel and make it 3, and this becomes 18. Now we've calculated these two areas, so we can add them together for what, 42 centimeters squared, but we don't have to put a unit on it yet. We're now ready to do this. Volume equals area of the base times the height. It equals 42 times the height, not the height of that triangle, but we have to go back here. The base of the right prism, 8 meters high. So 8 is the height of my three-dimensional object. So I multiply this by 8. I'm going to need a little multiplication work on that. 42 times 8. Remember that these like side multiplications, they're a part of your problem too. Don't put them on a piece of scratch paper or be embarrassed about them. They're an important part of your work. So keep it included so that anyone could follow you. 16, follow your work. So my calculation is that 336 meters cubed is the volume of the three-dimensional shape that has that as its base. Yay. All right, now come the kind that make me a little grouchy sometimes, you guys. I mean, that's dramatic, but you know what I mean. Look, I just put the blue lid on the orange marker. That feels jarring to me. Okay, 20.3. There are 5 examples in this problem, but the last one is the easiest, so get excited for that. The base of a right solid 10 kilometers high, whoa, that would be tall, is shown. Find the volume of the right solid. Dimensions are in kilometers. Okay, look at our shape. It's like a mailbox standing on its end, an old school mailbox. It's complicated and it looks kind of hard, but when John draws us this picture, we go, okay, we know how to find the area of a shape like that. You've been doing it. We split it into two, right? So let's carry on. I'm going to draw that base picture, because that's going to help me. Everything in orange is just like the book shows us. Dot, 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 dot. That helps us connect the two. This is my radius. It's 3, but I also remember, okay, the center to this point is also 3. The center to that point is also 3. But John gave us that as 6, so we don't even need that sneaky trick. All right, and so now we're trying to find the area of the base. Okay, I like to start my calculation with that, and I like to say so. So what I'm going to do is I'm going to say 1 and 2, just like we did last time. I don't know why I'm doing that in another color, but I am, just to help it jump out. So the first thing we want to do is find the area of this rectangle, apparently. Length times width. I write my formulas down so anyone could see how I did it. It's 6 times 5, and that equals 30. Don't worry about the units, just the calculation. All right. Now we need the area of this half circle. Oh, that's always a pain, isn't it? Because it's pi r squared, which is the formula for the area of a circle, but we have to divide it in 2. All right, we can do that. So that becomes 3.14 times r squared, r is 3, 9 divided by 2. All right, well, time to multiply. 3.14 times 9. 28.26. And then we have to divide that by 2. Okay, that's easy to divide by 2 because we just divide every single one of these digits by 2. So it's 1, 4, 1, 3. Doesn't that feel nice? I like it. Okay, so now we add those two together and we get 44.13 is the area of the base. Cool. Now we're ready to say volume equals area of the base times the height. So it equals 44.13 times, oh, John is nice to us. The right solid is 10 kilometers high. Multiplying by 10 is really easy, isn't it? So we're going to multiply that number time, and I'm going to put it like that rather than use a dot. And so all we have to do is move our decimal place once because dividing by powers of 10 are easy like that. 441.3 kilometers cubed. Yay. Oh, I'm sorry. It's supposed to be a smiley face. I was busy thinking about the unit. All right. That was kind of tricky, wasn't it? We had to just deal with the half circle there, but we did it. We had to deal with pi. We did it. It was good. This one, example 20.4, is almost easier in comparison. I would say that it is. This time, instead of having this wacky hybrid mailbox on its side shape, we just have a cylinder, a right circular cylinder. Right means that it's got straight sides. This is almost easier because we just use a regular circle as our base, all right? Now this time we don't get two pictures. All the information is smooshed into one. So I'm gonna go ahead and draw the three-dimensional shape because it's got numbers on it this time. We see this and I recognize, oh, that means the radius is 6. We've got this, and that means the height of the whole thing is 11. Okay, so this doesn't seem like very much information to me. And I read the problem. The right circular cylinder has a radius of 6 inches, got it, and a height of 11 inches, got it, as shown. Find the volume of the right circular cylinder. All right, same as always. First we find the area of the base. I'm not going to write it out anymore. The area of the base, and this, we just have this circle. That's all that we have. So it is a circle. It's pi r squared, right? Which is 3.14 times the radius squared. 6 squared is 36. I'm going to do that multiplication right here. 3.14 times 36. You go ahead and multiply 2. I get 113.04 as the area of the base. And then the volume equals the area of the base times the height. So that would be 113.04 times the height, which is 11. I'm not going to try and squeeze that on this page. I'm going to go to the next page and write it out. 113.04 times 11. I don't want to get this wrong. But it's really easy, right? 4, 0, 3, 1, 1. Put in a 0 and then write it again. 4, 0, 3. Add. And put in the decimal place. So I believe that my answer is 1,243.44. And I'm going to need a unit on this. I didn't get a unit when I went through it the first time. I go back and look, it says inches. So I put inches to the third power. Always volume is to the third power. Make my decimal a little bigger. Let me check. 1,243.44. Yay, we got it right. Okay. It looks good, right? So we've done some weird shapes. We're fine, we're cruising. We get to example 20.5, which is the last one in this lesson. We're feeling like, okay, we can manage this, but it's getting harder. Ay, ay, ay. We look at the picture for the last example and we go, what are you even talking about? What is that shape? I have never seen anything like it before. I don't know how to find the area of a shape like that. Is it a circle? Oh my gosh. A mini freak out commences, right? But then I look at the problem. The base of the right solid has an area of 52 feet. The height is 15. Find the volume. John gives us the area of the base. We don't have to figure it out. This one is actually easier than any of the other ones because he just skips us through that first calculation. He just tells us area of the base equals 52 feet squared. Height equals, what did he say? 15. So we don't have to do this whole first step that's been causing us so much drama. We can just get right into this. Volume equals the area of the base times the height, so it's 52 times 15. That's all there is to it, you guys. It's so fun. 52 times 15, or at least so easy. 10, 26, another 0. So the volume equals 780 feet cubed. Look how much faster that problem was than all these other ones we've been doing, and it's right. Okay, so the moral of the story is if John gives you a weird shape, practice problem C for this lesson, he'll just tell you what the area of the base is, and you have a short problem, not a long one. All right, lesson 20, volume. We will be using this calculation quite a bit. We'll have lots of time to practice it. It's a quick, simple formula to memorize. Once you remember what the letters stand for, that's all there is to it. And then we have a lot of different shapes that we can use as a base, and so finding the area of the base, that's really the trickier part. Once you get the area of the base, the calculation's a breeze, as this problem showed us. So, don't let it freak you out. Not that you would. Okay, lesson 20 is done. I'm done talking. Goodbye.